Chemical effects of electric current. Your elders might have cautioned you against touching an electrical appliance with wet hands. But do you know why it is dangerous to touch an electrical appliance with wet hands? We have learnt earlier that the materials which allow electric current to pass through them are good conductors of electricity. On the other hand, materials which do not allow electric current to pass through them easily are poor conductors of electricity. In class 6, we made a tester to test whether a particular material allows the electric current to pass through it or not. Do you recall how the tester helped us in deciding that? We found that metals such as copper and aluminum conduct electricity, whereas materials such as rubber, plastic, and wood do not conduct electricity. However, so far we have used our tester to test materials which are in solid state. But what about liquids? Do liquids also conduct electricity? Join the free ends of the tester together for a moment. This completes the circuit of the tester and the bulb should glow. However, if the bulb does not glow, it means that the tester is not working. Can you think of the possible reasons? It is possible that the connections are loose, or the bulb is fused, or your cells are used up. Check that all the connections are tight. If they are, then replace the bulb with another bulb. Now test if the tester is working or not. If it is still not working, then replace the cells with fresh cells. Collect a few small plastic or rubber caps of discarded bottles and clean them. Pour 1 teaspoon of lemon juice or vinegar in 1 cup. Bring your tester over this cap and let the ends of the tester dip into lemon juice or vinegar. Take care that the ends are not more than 1 centimeter apart, but at the same time do not touch each other. Does the bulb of the tester glow? Does lemon juice or vinegar conduct electricity? How would you classify lemon juice or vinegar, a good conductor or a poor conductor? When the liquid between the two ends of the tester allows the electric current to pass, the circuit of the tester becomes complete. The current flows in circuit and the bulb glows. When the liquid does not allow the electric current to pass, the circuit of the tester is not complete and the bulb does not glow. In some situations, even though the liquid is conducting, the bulb may not glow. It may have happened in activity. What can be reason? Do you remember why the bulb glows when the electric current passes through it? Due to the heating effect of current, the filament of the bulb gets heated to a high temperature and it starts glowing. However, if the current through a circuit is too weak, the filament does not get heated sufficiently and it does not glow. And why is the current in the circuit weak? Well, though a material may conduct electricity, it may not conduct it as easily as a metal. As a result, the circuit of the tester may be complete and yet the current through it may be too weak to make the bulb glow. Can we make another tester which can detect a weak current? We can use another effect of an electric current to make another kind of tester. Do you recall that electric current produces a magnetic effect? What happens to a compass needle kept nearby when current flows in a wire? Even if the current is small, the deflection of the magnetic needle can be seen. Can we make a tester using the magnetic effect of currents? You may use LED in place of electric bulb in the tester. LED glows even when a weak electric current flows through it. There are two wires called leads attached to the LED. One lead is slightly longer than the other. Remember that while connecting to a circuit, the longer lead is always connected to the positive terminal of the battery and the shorter lead is connected to negative terminal of the battery. Take the tray from inside a discarded matchbox. Wrap an electric wire a few times around the tray. Place a small compass needle inside it. Now connect one free end of the wire to the terminal of a battery. Leave the other end free. Take another piece of wire and connect it to the other terminal of the battery. Join the free ends of two wires momentarily. The compass needle should show deflection. Your tester with two free ends of the wire is ready. Now repeat the activity using this tester. Do you find a deflection in the compass needle the moment you dip the free ends of the tester in lemon juice? Take out the ends of the tester from lemon juice, dip them in water and then wipe them dry. Repeat the activity with other liquids such as tap water, vegetable oil and milk or honey. In each case, observe whether the magnetic needle shows deflection or not and record your observation. When free ends of the tester do not touch each other, there is an air gap between them. The air is a poor conductor of electricity. During lightning, an electric current passes through air. Now, if air is indeed a poor conductor under all conditions, whether other materials classified as poor conductors also allow electricity to pass under certain conditions. Actually, under certain conditions, most materials can conduct electricity. That is why it is preferable to classify materials as good conductors and poor conductors instead of classifying as conductors and insulators. Take about 2 teaspoonfuls of distilled water in a clean and dry plastic or rubber cap of a bottle. Use the tester to test whether distilled water conducts electricity or not. What do you find? Does distilled water conduct electricity? Now dissolve a pinch of cinnamon, common salt in distilled water. Again test. What do you conclude this time? When salt is dissolved in distilled water, we obtain salt solution. This is conductor of electricity. The water that we get from sources such as taps, hand pumps, wells, ponds is not pure. It may contain several salts dissolved in it. Small amounts of mineral salts are naturally present in it. This water is thus a good conductor of electricity. On the other hand, distilled water is free of salts and is a poor conductor. Small amounts of mineral salts present naturally in water are beneficial for human health. However, these salts make water good conductor, so we should never handle electrical appliances with wet hands or while standing on a wet floor. We have found that common salt, when dissolved in distilled water, makes it a good conductor. What are the other substances which can get dissolved in distilled water and make it conducting? Take 3 clean plastic or rubber caps of bottles. Pour about 2 teaspoonfuls of distilled water in each of them. Add a few drops of lemon juice or dilute hydrochloric acid to distilled water in one cap. Now, in the second cap containing distilled water, add a few drops of a base such as caustic soda or potassium iodide. Add a little sugar to the distilled water in the third cap and dissolve it. Test which solutions conduct electricity and which do not. What results do you obtain? Most liquids that conduct electricity are solutions of acids, bases, and salts. When an electric current flows through a conducting solution, does it produce an effect on the solution? Take out carbon rods carefully from two discarded cells. Clean their metal caps with sandpaper. Wrap copper wires around the metal caps of the carbon rods and join them to a battery. These two rods are called as electrodes. Pour a cupful of water in glass bowl. Add a teaspoonful of salt or a few drops of lemon juice to water to make it more conducting. Now immerse the electrodes in this solution. Make sure that the metal caps of the carbon rods are outside the water. Wait for 3 to 4 minutes. Observe the electrodes carefully. Do you notice any gas bubbles near the electrodes? Can we call the change taking place in the solution a chemical change? Recall the definition of a chemical change. In 1800, a British chemist, William Nicholson, had shown that if electrodes were immersed in water and a current was passed, bubbles of oxygen and hydrogen were produced. Oxygen bubbles formed on the electrode connected to the positive terminal of the battery, and hydrogen bubbles formed on the other electrode. The passage of an electric current through conducting solution causes chemical reactions. As a result, bubbles of a gas may be formed on the electrodes. Deposits of metal may be seen on electrodes. Changes of color of solutions may occur. The reaction would depend on what solution and electrodes are used. These are some of the chemical effects of the electric current. Electroplating. You know that a brand new bicycle has shiny handlebar and wheel rims. However, if these are accidentally scratched, the shiny coating comes off, revealing a not so shiny surface beneath. You might have also seen women using ornaments which appear to be made of gold. However, with repeated use, the gold coating wears off, revealing silver or some other metal beneath. In both these cases, a metal has a coating of another metal. Do you wonder how a layer of one metal can be deposited on top of another? For this, we need copper sulfate and two copper plates of size around 10 centimeter by 4 centimeter. Take 250 ml of distilled water in a clean and dry beaker. Dissolve 2 teaspoonfuls of copper sulfate in it. Add a few drops of dilute sulfuric acid to copper sulfate solution to make it more conducting. Clean copper plates with sandpaper. Now rinse them with water and dry them. Connect the copper plates to the terminals of a battery and immerse them in copper sulfate solution. Allow the current to pass for about 15 minutes. Now remove the electrodes from the solution and look at them carefully. Do you find any difference in any one of them? Do you find a coating over it? What color is the coating? Note down the terminal of the battery with which the electrode is connected. When electric current is passed through the copper sulfate solution, copper sulfate dissociates into copper and sulfate. The free copper gets drawn to the electrode connected to the negative terminal of the battery and gets deposited on it. But what about the loss of copper from the solution? From the other electrode, a copper plate and equal amount of copper gets dissolved in the solution. Thus, the loss of copper from the solution is restored and the process continues. This means that copper gets transferred from one electrode to the other. The process of depositing a layer of any desired metal on another material by means of electricity is called electroplating. It is one of the most common applications of chemical effects of electric current. Electroplating is very useful process. It is widely used in industry for coating metal objects with a thin layer of a different metal. The layer of metal deposited has some desired property which the metal of the object lacks. For example, chromium plating is done on many objects such as car parts, bath taps, kitchen gas burners, bicycle handlebars, wheel rims, and many others. Chromium has a shiny appearance. It does not corrode, it resists scratches. However, chromium is expensive and it may not be economical to make the whole object out of chromium. So, the object is made from a cheaper metal and only a coating of chromium over it is deposited. Jewelry makers electroplate silver and gold on less expensive metals. These ornaments have the appearance of silver or gold but are much less expensive. Tin cans used for storing food are made by electroplating tin onto iron. Tin is less reactive than iron, thus, food does not come into contact with iron and is protected from getting spoiled. Iron is used in bridges and automobiles to provide strength. However, iron tends to corrode and rust, so a coating of zinc is deposited on iron to protect it from corrosion and formation of rust. In the electroplating factories, the disposal of the used conducting solution is a major concern. It is a polluting waste, and there are specific disposal guidelines to protect the environment. Question answers. Most liquids that conduct electricity are solutions of acids, bases, and salts. The passage of an electric current through a solution causes chemical effects. If you pass current through copper sulfate solution, copper gets deposited on the plate connected to negative terminal of the battery. The process of depositing a layer of any desired metal on another material by means of electricity is called electroplating. When the free ends of a tester are dipped into a solution, the magnetic needle shows deflection. Can you explain the reason? Answer. The compass needle shows a deflection which concludes that current is flowing through the wire. The circuit becomes complete as the free ends of the tester are immersed inside the solution. So the solution is conducting solution, hence deflection is obtained in the compass needle. Name three liquids which, when tested in manner shown, may cause the magnetic needle to deflect. Salt water, lemon juice, vegetable oil. These liquids can be taken in a beaker to show the passage of electricity, as they will show a deflection in the magnetic needle. The bulb does not glow in the setup shown. List the possible reasons and explain your answer. The possibility of the bulb not glowing may be because of the following reasons. The liquid may be non-conducting. In this case, the circuit is incomplete and the current does not pass through the liquid. Electric current may be weak, for the circuit is made up of a material which is not a good conductor of electricity, or there is insufficient energy in the battery to generate electricity. A tester is used to check the conduction of electricity through two liquids. It is found that the bulb of the tester glows brightly for liquid A, while it glows very dimly for liquid B. You would conclude that liquid A is better conductor than liquid B. The conductivity of the solution determines the amount of current flowing through the solution. The greater the conductivity, the greater will be the quantity of current passing through the solution, and the lesser the conductivity, the quantity of current passing through will be correspondingly less. So the conductivity of liquid A is more than the conductivity of liquid B. Does pure water conduct electricity? If not, what can we do to make it conduct? Pure water does not conduct electricity, as it does not contain any type of salt. Adding a small amount of common salt will turn the water into a conducting medium. In case of fire, before the firemen use the water hoses, they shut off the main electrical supply for the area. Explain why. Answer. In case of fire, before the firemen use the water hoses, they shut off the main electrical supply for the area, because water sprayed from the hose might conduct electricity, which may come in contact with electrical appliances, which increases the chances of electricity passing through the wire. This may hurt the firemen. A child staying in a coastal region tests the drinking water and also seawater with his tester. He finds that the compass needle deflects more in the case of seawater. Can you explain the reason? The amount of dissolved salts present in the seawater is more than that of the drinking water. So seawater will be a better conductor than drinking water. That is the reason behind the increased deflection of the needle in the seawater than compared to the drinking water. Is it safe for the electrician to carry out electrical repairs outdoors during heavy rains? Solution. No, it is not safe to repair electrical appliances outdoors during heavy downpour. Rainwater is composed of a certain percentage of dissolved salts, making it conductive. This may cause electric shocks and harm the electrician while working outdoors during heavy downpours. Paheli had heard that rainwater is as good as distilled water, so she collected some rainwater in a clean glass tumbler and tested it using a tester. To her surprise, she found that the compass needle showed deflection. What could be the reasons? Solution: rainwater is composed of a certain percentage of dissolved salts, making it conductive. This results in the deflection of the compass. Prepare a list of objects around you that are electroplated. Answer: chromium plating. This is done on exterior parts of automobiles in order to obtain a shiny appearance. Gold plating. Silver ornaments are coated with a thin layer of gold, and the product is called gold plated ornaments. Zinc plating. Iron used for construction is coated with zinc layer in order to protect them from corrosion and rusting. The process that you saw in activity is used for the purification of copper. A thin plate of pure copper and a thick rod of impure copper are used as electrodes. Copper from the impure rod is sought to be transferred to the thin copper plate, which electrode should be attached to the positive terminal of the battery, and why? The thick rod of the impure copper plate is to be attached to the positive terminal of the battery because when the electric current is passed through the copper sulfate solution, it gets dissociated into copper and sulfate. The free copper, being positively charged, gets drawn into the negative terminal of the battery and gets deposited on it. On the other hand, the loss of copper from the solution is regained from the impure copper rod, which is attached to the positive terminal of the battery.